Now we'll draw the circuit for t greater than 0 and less than 4 seconds. Okay. So when you will draw the circuit, you will get 4 ohm here. This circuit is open, so this is useless. I'm not drawing it. 6 ohm and wait a minute. 40 volt. So the current I0 minus is 0, right? So I0 plus will be same. 0, current is 0 means it's open circuit. It's open circuit. But this is at t equal to 0 plus. Okay. But in the last time we have seen the formula for current. IT is nothing but I infinity plus I0 minus I infinity e to the power minus t by tau, where tau is in the case of inductor L by R. Is it okay? So see, we are closing the switch at t equal to 0. At t equal to 0 we are closing it. At t equal to 0 plus, the current will be 0 in it. But after this time, the circuit will become steady state. Means at t equal to 4 seconds, what will be the condition for the circuit? Circuit will be in a steady state or not? This is a long time the circuit is working in. It means circuit reaches to the steady state. Okay. So in the steady state, the inductor works as a short circuit. So for the steady state current I'm calculating, I will short it. Everything will remain same. And this current I'll say infinity for this reason. I'm talking in this reason. I'm calculating I infinity. Why I'm calculating infinity? Because my task is to calculate IT. For IT I need I0 and I infinity. I have I0 already calculated to 0 ampere. Now I need I infinity for this domain, this range. So at t equal to 4, I'm taking I infinity, steady state current. So I infinity is nothing but 40 divided by 10. This is 4 ampere. So 4 ampere is the current. Now we have to calculate IT in the region 0 to 4. Okay. So I need another thing, and that is tau. For the tau I need L by R. I have L, I need R also. So to calculate R equivalent, we'll calculate it from A and B. Right. So A and B, how much resistance we are seeing from A and B? 6 and 4. They are 10. They are connected in series. So this is the 10. It will be short circuited because we are calculating the R equivalent. So R is nothing but the 10 ohm. What is your L? This is 5 Henry divided by 10. This is 1 by 2. Is it okay? So for region 0 to 4, your current IT is now we can put the values 4 plus 0 minus 4 e to the power minus 2t. So your equation is finally 4 minus 4 e to the power minus 2t. Okay. Your current IT is 4 minus 4 e to the power minus 2t ampere. But please remember, this current is for the region, t0 to 4 only. Okay. And what was the current for t less than 0? It was 0. We calculated it, right? Now, the first one is over, second one is over. Now come to the third one. And third one is saying that when t greater equal to 4 seconds. Okay. So we are introducing this circuit in the entire circuit at t equal to 4. So your new circuit will be S1 is closed. This is 40 volt. Fine. We are closing this. We are getting 2. This is 10 volt. And like this. 6. Okay. So remember one thing. When you are connecting at t equal to 4 the switch S2, what is your task now? Your task is to find out IT, right? Again, for the IT you need I infinity plus I0 minus I infinity e to the power minus t by tau. Now tell me how you will calculate I infinity. It's very easy to calculate I infinity. Circuit in the steady state. In the steady state, the inductors behaves like short circuit, right? So this is kind of thing. But what about I0? I0 is not this one, okay? For this circuit, I0 is nothing but the current at 4, exact 4. For this, the steady state is I4 now. Sorry, t equal to 4 second now. So for this circuit, I0 is nothing but the current at t equal to 4 second. 4 second, because at 4 second we are closing the switch. We are closing the switch. It means before closing the switch means t equal to 4 minus and t equal to 4 plus, the current will be same. 4 minus what is the current? We can get the current value by this equation. I4. 4 minus 4 e to the power minus, this is 8. So if we will calculate this, it will be near around 2 ampere. Okay. It will be near around 2 ampere. Now you get I0. Now calculate I infinity. This is the case of I infinity. We are shorting the inductor and we have to calculate the current over here. Assume this is V by nodal analysis. V minus 40 divided by 4 plus V minus 10 divided by 2 plus V by 6 equal to 0. Once you have the value of V naught or V, you can get the current in this. So by this equation easily I can get this. The LCM will be 12, 3V minus 120, 6V minus 60 plus 2V equal to 0. 3, 6 and 2, 11V. 11V is equal to 180. Okay. Am I right? Let me check once. 2, 6 are 6V and 3V, 9. 9 and 2, 11. So V is something 180 divided by 11. So you can get the value of this. I infinity I am saying, because the circuit is working in the steady state. This current will be 180 divided by 11 into 6. 6 3s are, this is 30 by 11. The current value is 30 by 11 if I am right. Maybe here the calculation mistake. So if you people solve it again, you can find out. But I am thinking that I am right. 30 by 11, right? So we put the values in this equation. I infinity 30 by 11 plus 2 minus 30 by 11 e to the power minus t by tau. You need tau over here. So for this circuit, you have to calculate R equivalent across the point A and B. So we'll short all independent voltage sources. So this 4 and this 2, they are connected in parallel. 4 into 2 divided by 6, 2 3s are 4 by 3 plus 6. This is overall, right? 3, 4, 18, 22 by 3. 22 by 3 is nothing but the R equivalent. So what is the tau? L by R. L is 5 into 20 by 3. Is it okay? This is 15 by 22. We'll keep this value over here and we'll get the IT. So this is all about this question. I hope you understand this. Come to the next one. The second order circuit. What second order implies? We have seen the first order circuit, right? In the first order circuit, if you observe carefully, we are having only one, storing device. Like capacitor or inductors. So in the circuit, if you are having one single or a single storing device, it will be surely first order circuit. But if you are having two different energy sources or energy storing devices, then circuit will be second order. A second order circuit is characterized by a second order differential equation. It consists of resistors and the equivalent of two energy storage elements. Remember, two. See, in this circuit, we are having two energy storing elements. Two energy storing elements. Two energy storing elements. And different, right? Here also two energy storing element. That's why the circuit is second order. So sometimes we get the questions from this portion also, right? So based on this second order, I have one question: find the complete response V and then I for t greater than 0 in the circuit of the figure. Okay, at t equal to 0, you are closing the switch. You have to find out IT over here, and you have two dependent sources, two energy storing elements, capacitor and inductors. So here you can't apply that formula I infinity and something. Why? Because that was the I infinity was the formula for IT formula was I infinity plus I0 minus I infinity e to the power minus t by tau. This was the formula validated for the inductor current only. Means in the circuit you are having only inductor, but here you are having capacitor also, and they are asking for the I. Okay, so how to solve this type of circuit? So this question I'll solve in later stage after introducing the concept of Laplace transform, right? So our next topic is application of Laplace transform in circuit analysis. Friends, you have seen, I think, Laplace transform in the mathematics and signaling system, where we can convert the time domain into frequency domain. Is it okay? Means if you have the value of current in time domain, we can convert it into Laplace domain, right? Denoted by S. S is nothing but j omega. This is the frequency part. Okay, so simply we are transforming time into the frequency. So the Laplace transform is an integral transformation of a function ft from the time domain into the complex frequency domain. Steps in applying the Laplace transform. So what are the steps? Transform the circuit from the time to S domain. First, if you are having any circuit, first transform it into the frequency domain S. Solve the circuit using nodal analysis, mesh analysis, and all other these things, right? Take the inverse transform of the solution and thus obtain the solution in the time domain. What they are saying, see, we are solving questions in which we were finding IT greater than 0, like this they were asking, right? So instead of IT, I can find out IS also. How I can find the IS? First, I'll convert the time domain circuit into frequency domain or S domain, Laplace domain, right? Then I'll take inverse of it. So again, I'll get the IT. So this is actually very easy to get answers from Laplace transform, the application of Laplace. Okay. So you have seen this question, and this question will solve in the later stage by Laplace transform. Okay. If you will solve this in time domain, it will take time to you. Okay, it will take hardly 5 to 10 minutes to solve this question. But if you will solve this question with the help of Laplace applications, it will be very easy to you. Okay. Now, register the voltage current relationship in the time domain is, if you have resistance R and that resistance current IT is flowing, so VT will be IT into R, simple. But what if you transform the circuit in the form of Laplace transform? In the Laplace transform, the VT will become VS, R will be as it is, IT will become IS. This is the transformation of the resistor in Laplace. Okay. So what about inductor and capacitors? For the inductors, you know the equation is L di by dt. You know or not? Tell me. Friends, if you are having VT, to convert it into the Laplace domain, simply you are having VS. If you have IT, simply you will be having IS in the Laplace. But here, now we are having the relation between current and voltage in the inductor. So this Vt will become Vs simply. L is as it is. Here, when you will apply this, so if you remember, this will become SIS minus I0 minus. I think you have done this in the mathematics. Laplace transformation. The transform of the differential is nothing but SIS. Okay, where is order 1 if the differentiation is the order 1, and this is the initial condition. Okay, so if you will open this, it will become SLIS minus LI naught. Is it okay? This is nothing but Vs. This is nothing but Vs. So in time domain, simply you have Vt, you have inductor L. In that inductor you are having It simply. So you are getting this formula. But what if you changed it into the Laplace domain? Laplace domain, the equation will be like this. So this is Vs, this is Is, another voltage is SLIS. So we need SL also. SL and IS, they will contribute SLIS voltage. And this is the initial condition minus LI0 naught. So directly I am taking LI0 naught. Is it okay? So this will be the equivalent circuit in the Laplace domain. This is the equivalent circuit in the time domain. Further, you can simplify this circuit. What you can change, source transformation you can apply over here. So source transformation, this is the voltage source connected in series with the resistance. This is the resistance, okay. This is in ohm. This is inductive reactance. Okay. So the circuit is like SL in parallel with I0 minus by S. This is the initial current. If initial current is 0, your circuit simply will become SL, IS, and here Vs. This is the time where L is going to convert into SL. So please remember, for R, the time domain is R, Laplace domain is R. For L, Laplace domain is SL. Here you can see this, right? Come to the capacitor now. For the capacitor, we know the relation It is nothing but C dVct by dt. Again, we will take the Laplace transform. It will become Is, C as it is. This will be SVs minus initial condition, initial values, right? So when you will open it, CS Vs minus V0 minus into C. Is it okay? So if you want to write this equation in the capacitor first, the capacitor given in the time domain, Vt is the voltage across the capacitor, It is the current into the capacitor, and V0 is the initial condition across the capacitor. Now you are changing it, so you need this equation. Is is over here, Vs is over here, Is, and this is 1 by St, and this is the how this came. See, can you take this Vs equation? Only Vs equation. Vs will be this side and everything will go that side. Is by 1 by Cs and minus V naught. What I am doing, I am taking to this side, so it will be plus V0 and divide by S only. Is it okay? So you need to fabricate this equation. So Vs is over here, Is will multiply with Ist. Is will multiply with 1 by Ist. So Is 1 by Cs and plus V naught by S. So V naught by S. This is your equation. Further, you can transform it. So Is is as it is. The voltage and resistance. This is the capacitive reactance in ohm, means resistor. Resistance and voltage source, they are connected in series. We can convert into the equivalent current source and that particular resistor in the parallel. Now, if V naught is here, if V naught is infinity, 0, So the current here is 0, so it will be open. So you can see the capacitor will change into the 1 by SC. So here again I'm telling R will convert to R, we can write L is LS, C we can write 1 by SC. Is it okay? So here resistor ZS S domain will be R, ZS for inductor will be SL, ZS for capacitor will be 1 by SC. So you can see over here, the R will convert to the R. The circuit is like this. Now this is the inductor circuit, IT in L. So you are converting into the Laplace. VT will become VS, IT will become IS, L become SL. IT become IS, VT become VS, C become 1 by SC. We have seen this. Is it okay? Now come to the question. Find V naught T in the circuit assuming 0 initial conditions. They have given the initial conditions is 0. So what about this? This is UT given, right? So UT. Remember the conversion of UT is 1 by S in the Laplace domain. So we'll take the Laplace transform of this circuit. Resistor will as it is 1. This will be 1 by S. This will become 1 by ST. 1 by S, C is nothing but 1 by 3. What about resistor? Resistor will be same as it is. And this will become S into 1. So only S. And the voltage across this will be V naught S. V naught T is given, it will be V naught S. Okay. Everything is fine. This 3 will go up. So it will become 3 by S, 5. Now what he is asking? He is asking that find out V naught T in the circuit assuming 0 initial conditions. So in this case we can find out the value of V naught S, means the value of voltage across the S. So though we are working in the Laplace domain, frequency domain, at the output stage you will get the output in the frequency domain, means you will get V naught S. So whatever you will get, you have to take it transform, Laplace inverse transform, so you will get V naught T. Because in the question they are asking V naught T only. Okay, so how to solve this circuit now? It's very simple to get V naught T. Here I can apply nodal analysis. Okay, nodal analysis. I'll solve this nodal analysis. V minus 1 by S divided by 1 plus V divided by 3 by S plus V minus 0 divided by 5 plus S. This 5 and this S, they are connected in series. That's why I'm adding them. Okay, equal to 0. So here we can get the value of V. Once we get the value of V from this equation, okay, let me try it. It is easy. So I'll take 5 plus S LCM. So 3, 5 plus S, V minus 1 by S plus, okay, I'm leaving it for you, okay. You can solve it. Now what is the procedure actually? Once you will get the VS, suppose this is VS, give it name. You have to calculate this current. IS, I'm giving the name. So once you get the VS, you can easily get IS or not, because IS is what? IS is nothing but VS divided by 5 plus S, 5 plus S. And then you can get the V naught also. You will multiply that current with S, you will get the V naught. So V naught S you will get in the S domain. Okay. Then you will take the inverse. It will be in time domain. Okay. This is all about to this. But don't leave it. It's up to you to solve it. Okay. Now come to the next question. For this also I'll provide the hint to you. See here they mention the initial conditions. Initial values given. So come to this first. 10 e to the power minus t ut given. Okay. So we have to convert it into Laplace S domain. So this will be S plus 1 if you remember. if you remember this property. In the mathematics you have done this, okay? So instead of this you will write now 10 divided by s plus 1. Instead of 10, 10 will be as it is, 10 will be as it is. This will become 1 by sc, means 10 by s. Okay, what about this? The Laplace transform of del t is 1. So this is simply 2. Okay, so your new circuit is, here I am drawing your circuit. Here the value is 10 by s. Okay, fine. This is the voltage source and the value of this source is 10 divided by s plus 1, and this is simply 2 ampere. Now what they are asking, they are asking V naught T. Here is the V naught T. Means the voltage across this capacitor at this point, V naught S I can say. V naught S is nothing but the voltage across this. Is it okay? Now can you apply over here nodal analysis again? Yes, you can apply. This is the same node, V naught S, because there is no element existing here. So V naught S, this V naught S minus 10 upon s plus 1 divided by 10 plus V naught S divided by 10 plus V naught S divided by 10s, and upcoming current 2 equal to 0. In this equation you have only V naught S unknown. But okay, I made a mistake over here. For the voltage capacitor they have given the initial voltage also. So how to replace initial voltage? We have seen last time. See, here is the capacitor, here is the capacitor. In the capacitor in series with V naught by S also I have to write, right? So the transformation of this circuit will be having another term. Here I have to write V naught by S means 5 by S. 5 by S also. Okay. So this circuit will be plus 5 by S, like this. So here also you will get this is homework to you, will get V naught S and then take it the Laplace transform, you will get the answer. I hope this is clear to you. Come to the transfer function. So about the transfer function we are talking in control system, right? The starting of the control system is based on the transfer function. What is the transfer function? See friends, if you are having system, this is the system. Into this system you are providing some input and you are getting output. So the system is contributing TF into the input, means output is nothing but TF into input. Okay, but friends, it will be in S domain. It will be in S domain only, means the output will be S TF and input will be in S domain. Then only this relation exists. So that's why HS is the transfer function of the system. HS is nothing but YS divided by XS. The YS is nothing but system output, XS is nothing but system input, HS is nothing but the system transfer function, and the transfer function is given by YS divided by XS. I hope this is clear to you. So sometimes we have asked the question from this transfer function concept. Okay. See, the transfer function of a linear system is given like this. Transfer function is given. Now find the output yt due to the input this and its impulse response. Impulse response is nothing but the transfer function. Okay. But they are saying find the output yt due to this. They are given system. The transfer function of the system is given S plus 6. Now you are providing some input. This is in time domain, convert into the frequency domain. So if you will convert this in frequency domain, it will be 5 divided by S plus 3. Now you are getting yt. So instead of yt, you are getting ys. Now we can find out the ys value, then we will take the inverse of this. So ys is nothing but multiplication of these two things, right? So 5 s plus 3 into what is this? 2s divided by s plus 6. So this is nothing but 10s divided by s plus 3 and s plus 6. Okay. So how to solve this? Okay. Remember this equation, 10s s plus 3 s plus 6. The equation was 10s s plus 3 s plus 6. This was nothing but ys. Okay. Now partial fraction. By the partial fraction I can resolve it. This will be a s plus 3 plus b s plus 6. Okay. Okay, I'll not go into the partial fraction. Directly I'll do this. The value of a is nothing but, okay, instead of s I'll put minus 3. 10 into minus 3 divide by minus 3. So 3 divided by s plus 3. This will be the value of a. Come to the b now. S plus 6. Instead of s I'll keep minus 6. So this is 10 minus 6 divided by minus 6 plus 3 minus 3 minus 3. This minus 3 to the, so here 20 divided by s plus 6 plus, what about this? 3 will get cancelled. This is minus 10 divided by s plus 3. Now this is your ys, but they're asking for the yt. For the yt I have to take the Laplace inverse Laplace transform, right? So this will become yt. What is the inverse of this? Minus 10 e to the power minus 3t ut. This is the inverse of this. This is the mathematical part, okay? That's why I'm doing it very fastly. This will be e to the power minus 6t ut. This is nothing but the yt for this. This is all about the transfer function, okay? Now friends, the second question is find the transfer function. What is the transfer function? And the transfer function for this circuit is, first I'll convert this circuit into the S domain. So this will be S, this will be VIS, and I don't know what this value is given. I think they are taking S only. And this is 1, 1, 1, 1. Everything is. The transfer function for this system will be, HS is nothing but output. What is the output? We notice taking over here. Divide by, what is the input? VIS. Here we are giving this. So, can you solve this? It's very easy. Okay. So I gave the hint to you. Now calculate the V0 S. In terms of VIS, divide both of them, V0 S and VIS, you will get the transfer function of the circuit. Okay. Now come to the problem sections. So friends, see, in this transfer function problem, we are having 2 or 3 times single types or single patterns of problem. And the problem was, wait a minute, the transfer function of the system was given HS 2S S plus 6, suppose I'm taking. They were saying this is the system. Into this system we are providing input A cos omega t, like this. What will be the output? What will be the output? The question is like this. So friends, the output of this type of question in which the transfer function is given, input is given, first they given the transfer function. Now they're asking for this input, what will be the output. So there is an easy way to solve this type of circuit. So output of this circuit will be A into some magnitude cos omega t plus phi. So everything is given A omega, but 2 things are new, M and phi. What is this M? Okay, let me take one example. So we'll get it. Your system is given S plus 1. To this system you are giving 2 sine 2t as an input. Question is what will be the output. Here the omega is given 2. Okay. And the output of this circuit will be 2 into some magnitude sine omega t plus some phase difference. Okay, how to calculate M? To calculate M, take the magnitude of this. The HS is given, right? S plus 1. Take the magnitude of this. Magnitude of this will be omega square plus 1 and root also. Okay. Now the omega is given over here. So this will be root 5. This is nothing but my M. So the answer is 2 into 1 by root 5 sine 2t plus phi also. I need phi. How to calculate phi? Take the phase angle of this. The phase angle of this is, the phase angle of this will be minus tan inverse omega. Omega is 2 given over here. So minus tan inverse 2. So whatever angle you will calculate, this is your phi. Just put phi over here. This is minus tan inverse 2. This is nothing but the value of output, whatever they are asking. So 2 or 3 times the same concept came in the GATE exam. So it's very important. Okay. Now come to the problem section. For the circuit shown in the figure, the inductor current just before t equal to 0 is, where is the inductor? Here is the inductor. T equal to 0. At t equal to 0 we are closing it. Means before that it was opened. So the situation is 10 ampere connected with 2. The switch was open. For the steady state it will be short circuit. 3 ohm, 2 ohm, IS. Okay. Oh, sorry. IT. Simply we have to calculate IT, right? So the IT will be, okay, we can apply here the current division rule. I need current in this branch. So this branch current is opposite branch resistance into main current divided by 2 plus 3. It's 5. 5 2s are 4 ampere. So this question is answered. IT equal to 4 ampere. Come to the second one. Okay, now come to the second one. They are saying find the time constant of the RC circuit. Time constant. Can you find out the time constant? Time constant, for the time constant in the capacitive circuit, tau is nothing but RC. So you have the value of C, yes, it's given over here. This is the C value. But you don't have the value of R. But you can calculate that. Means you have to calculate R equivalent across A and B. So what is the procedure? Across the A and B, you have to calculate R equivalent. R equivalent. Okay. So this is 80 as it is, 120 as it is. What about this source? Though this is the voltage source, so we'll short it. Instead of voltage source, if we have current source, we have to open it. So this is 120, 80 and 12. 120 and 80 they are connected in parallel combination. So 120 into 80 divided by 200. Yeah, means 120 plus 80. This will go out. 2 4s are, and this is 48. 48 ohm. So the parallel combination of this circuit connected in series with 12. Okay. How? Let's see. Now you resolve these parallel branches, and the new one is 48 ohm. Now this 48 and this 12 they are connected in series. So the resultant is, the R equivalent is 50 ohm. 15 ohm for this circuit. So once you get the value of 50, now you can get the time constant. Okay. The time constant tau is nothing but RC. What is R? R is 50 and C is 0.5 milli. 0.5 milli. Okay, so this is 25 millisecond. This is nothing but the time constant. Remember, while calculating the time constant, we need the R, or I can say the tau is nothing but the R equivalent into C. C is given to you already, but you have to calculate R equivalent. And remember one thing, the R equivalent always calculated across capacitor. Across capacitor, for which we have to calculate tau. Right? Means how much, see, resistance is seen by this capacitor. That one we are multiplying with C and getting time constant. I hope this is clear to you. Okay, come to the next one now. In the third question, they are saying the switch in the figure has been in position A. Okay, position A for a long time. Means at position A, the circuit is in steady state. Assume the switch moves instantaneously from A to B at t equal to 0. At t equal to 0, the switch is moving to B. Find V for t greater than 0. Where is the V? Here is the V. For the t greater than 0 and V is across the capacitor, we know the formula. Vt is nothing but V infinity plus V0 minus V infinity e to the power minus t by tau. Is it okay? This is the formula. We need V infinity and V0. First calculate the V0. The switch is at this position. The circuit is in steady state. The capacitor will be open circuit. The capacitor will be open circuit. This entire 40 volt voltage will be seen to V capacitor only. So V0 minus is nothing but 40 volt. So according to the capacitor equations, the V0 minus will be equal to V0 plus. Is it okay? Now V0 is fine. We got it 40. Come to the V infinity. Where is the V infinity we will get? In the second step, the circuit is moving to the B. Now circuit is coming here, over here. Okay. Now tell me, is there any independent source, voltage source over here in this circuit? No. So entire energy will be delivered to this 2K by capacitor, because the capacitor is stored 40 volt, right? This 40 volt will be drained to the 2K. And remember, this is the RC source free circuit. At the source free circuit, at infinity, the voltage will be 0. Means at infinity, will there any voltage exist on capacitor? Whatever the stored voltage it has, it will be drained. So at V infinity, the voltage is 0. Now, what about the time constant? Time constant will be seen by over here. Let me erase it first. Now you have to calculate time constant. This is A, this is B. Across AB you have to calculate. Now, where you will connect this circuit? Over here or over here? Over here you will connect, because this is your steady state condition. Okay. So, you are seeing here 2K resistance. Your resistance is 2K. Your capacitance C is given 10 micro. So, your time constant is 10 micro into 2K. Is it okay? So, 10 to the 20, 10 to the power minus 3. This is 20 milli. Are equal to 20 milli. So, Vt is nothing but V infinity. V infinity you calculated at 0 plus 40 minus 0 e to the power minus t by tau. Tau is nothing but minus 3. So this is nothing but 40 e to the power 50 t volt. This is your answer. Okay. Now come to the fourth one. The switch in the figure has been closed for a long time. It was closed for a long time and it opened at t equal to 0. Find Vt for t greater than equal to 0. Where is the Vt? Here is the Vt. So this question is similar to this question only. So this is homework to you. Okay. Come to the next one. And the next one, assume that the switch in the figure has been in position A for a long time. So here it was initially. Okay. Time, and it's moved to position B at t equal to 0. At t equal to 0, the switch is moving to B. Find out V naught t for t greater than 0. V naught t, so this question is also similar to third and fourth. You can do it. This is also homework to you. Come to this. For the circuit shown in the figure, find I naught. Where is the I naught? Here is the I naught. At t equal to 0, you are opening it. Okay, and they are saying that find out I naught t. The question is I naught t. I naught t across the inductor, simple I infinity plus I0 minus I infinity e to the power minus t by tau. This is equation. In this equation you need I infinity, I0 and tau. Three parameters you need to get the value of I naught t. So I'll solve this. Initial current I can get it because the switch was closed before t equal to 0. Okay, so circuit was working in the steady state. So in the steady state, the inductor becomes short circuit. And you are having 24, 2, 3. First we will get the current over here, then we will divide the current. So what is the current? Can you find out it? Yes, you can find. You can apply nodal analysis or directly you can do it. How? Find out the equivalent resistor across 24 volt, divide it by the resistor, we will get the I, then we will divide this I into these two branches. So 8 and 4, they are connected in parallel. 8 into 4 divided by 12. 4 3s are 8 by 3 is the resultant. Okay, 8 by 3 is connected with 3 in series. Okay, is it right? 4 3s are 8 by 3. Yeah, this is right. So 3 plus 8 by 3. So this is 9 plus 8 by 3. 17 by 3. 17 by 3 is your resultant. So what is this current? Current is nothing but 24 divided by 17 is 3. Okay, so this is 72 by 17. 72 by 17 you have to divide and you want to get the value in this branch. So 72 by 17 multiply with opposite branch resistance, divide by summation. 8 and 4, 12. This is 6. This is 24 by 17. This is your current. So you got the current I0 minus. You got the current I0. I0 is nothing but 24 by 17 ampere. Now you need to take I infinity. Now you will open the circuit. Now in this circuit you are having this source free RL circuit. Source free RL circuit. What will be I infinity? Yes, it will be 0 because at t equal to infinity, the entire stored current will be drained to the through the resistances. Okay, so it will be 0. Now what is the time constant? Time constant you have to find across A and B. A and B, 4 and 8, they are connected in series. So this circuit is not in the picture. So 4 and 8, they are connected in series. 8 and 4, 12. So time constant L by R. What is L? L is 4 and L is 4 divided by 12. This is 1 by 3. So you get the value of 1 by 3, tau value also. Now you are having formula in your hand, you can apply. Okay, come to the next now. In the circuit shown in the figure, find IT for t greater than 0. I naught 2 is given over here. Okay, we have to calculate this I naught 2 is given, and this and that. So here I can apply the your Laplace domain. I'll find out this with Laplace domain. It will be very easy to find out this by Laplace. Okay, so I'll apply the Laplace. I will convert the circuit into the Laplace. 10 will be as it is 10. This will become 6s. The current will become Is. This dependent source will become 0.5 Is. Okay, so though this is the numeric value, so divide by S also. It's kind of ut, right? 0.5 I ut. So I can take it 0.5 is by s. Okay. Come to this. This is 40. Okay. So this is about this source 0.5 is by s, and this is resistance. So it will be as it is 40. Now see friends, they have given the initial values. So whenever the inductor replaced by or inductor having initial value, how to replace it? I think you have seen in this. We already discussed about this. Here is the inductor. See, if the initial values are given, so in series we'll add that initial value and we'll multiply by L into I0 minus kind of thing. Okay. So we'll replace that inductor by this. Wait a minute. So here I'll add 2 into L. What is the L? 6, right? So this is 12 volt. Okay. Now they're asking for the IT. Where is the IT? Here is the IT. Here is the current. Here take voltage V and apply nodal analysis. You applied nodal analysis, you'll get some voltage over here, and then you can find out the IS. In the next step, you have to take the inverse of IS and you will get your answer. Okay. But suppose there is another method to solve this circuit. Let me try over here. What is the voltage? So take it V. So V divided by 40. Current in this branch is 0.5 I. So this is the outgoing, that's why I'm taking plus sign, and this minus I is coming, equal to 0. So V by 40, and this is 0.5 I minus I. So it will be 0.5 I this side. Okay. So 0.5 I multiply this 40 over here. So V equal to 20 I. This is equation 1. I think this method is easy to solve. Okay. Now, what is the V? Tell me the voltage drop over here. Plus minus 10 I. What is the voltage drop across this? L di by dt. If you remember, L is 6, di by dt. Okay. Direction is plus minus. So V is nothing but, this V is nothing but minus of 10I plus 6 di by dt. This is nothing but your V. Okay. Can you replace it over here? Yes, I can replace. So minus 10I plus 6 di by dt equal to 20I. This minus sign will go here and it will come here. So equation will be like 6 di by dt, 6 di by dt, and plus 30I equal to 0. Now this is your differential equation, if you remember. You can take 6 out. So it will be di by dt plus 5I equal to 0. Now this is your differential equation. Can you solve this easy differential equation, di by dt plus 5I? The differential equation is by dt plus 5I equal to 0. Means this is m plus 5 equal to 0, m equal to minus 5. So solution for this equation means it is nothing but constant C1 e to the power minus 5t. Okay, this is your answer. Now you have to remove this constant term. Yes, you can remove by applying the initial condition. I0 is given as 2, C1 e to the power minus 5 into 0. So C1 equal to 2. So the current IT is 2 e to the power minus 5t. So better go with this rather than Laplace transform, because in the Laplace it will take time again. Okay. Come to the 8th one, and this question I'm leaving for you. Okay. So this is all about this lecture, and I hope you got the concepts. We'll meet again and we'll start the 5th unit. Okay. Do homework and do whatever the question I'm providing the classes. We'll meet again then. Till then, take care and bye.